Today's topic is slope, Unit 3, Day 2. Our objective is I will be able to determine the slope of linear function given a table, graph, points, or an equation. So first off, we need to think about what is slope. Now slope is when the data is linear, the rate of change is constant. The slope of a line is a ratio of the vertical change to the horizontal change of any 2 points on a line. Now this is like the formal definition, but maybe it doesn't make a lot of sense yet. So I want you to think about a hike. And you're going on a hike on a mountain. And let's say that this mountain is a pretty steep mountain. So your slope is a description for how steep your mountain is when you're climbing. And the number that we use represents some amount that is a rise and some amount that is a run. So oftentimes you'll hear slope referred to as this rise over run. How much do you go up or down for every portion you go to the side? All right, so the way that I want us to think about slope is our vertical change over our horizontal change, or rise over run. You might also see it as delta y. So delta stands for change in your y direction over delta x, which is the change in your x direction, okay? So if you're going up a really steep mountain, then you have a higher slope. And if it's like barely a hill, then it's a pretty low slope. Now, if you're given two coordinate points, so coordinate points are when you have your parentheses, you can use the slope equation to determine the slope of those two coordinate points. So for example, if we have the point 1, 2 like that, and then 3, 4 like that, you have that line. Now, how steep is that line? Well, you can find out using a slope equation, y2 minus y1 over x2 minus x1. So your first value here is x, and it's the first x, so we put x1. Your second number is y1, x2, y2. And you can use those to put into our slope equation and determine the slope. A couple of things to keep an eye out for is remember your negatives, okay? You always have to have a negative in between your x and your two y values and your two x values, even if you have a negative y or x value. Now, I want to introduce you guys to Mr. Slope Guy. So, if you have a line with a positive slope, it will slant upwards from left to right. So when you're going left to right, your points go up. Negative slope, it'll go down when going from left to right. Now a line with a slope of 0 is just a horizontal line. So it could be that horizontal line here. It could be this horizontal line here, or this one right here, so on and so forth. And then a line with an undefined slope is vertical. So any line that goes straight up and down has an undefined slope. Now, one way that I remember all of these different positive and negative slopes is by doing Mr. Slope Guy. So I have a positive slope. It looks like this. And I have a negative slope. It goes downwards from left to right. When it goes straight up and down, my equation does, then the nose ring means that it's undefined. And then when I go straight horizontal, left to right, his dimples are zeros, right? So that means positive slope, negative slope, undefined, 0. Okay? So this really helps if sometimes you mess up your negatives when using your slope equation. This is a good way to double check all of your answers. Now let's take a look at this first teacher example. It gives you the graph and it asks, what is the slope of this linear function? The first thing that we need to do is find some coordinate points that are preferably straight on an intersection of whole numbers. For example, there's this point here and this point here, right? If I were to give you the coordinate points, it would be -2, -5, and this would be 2, 5. Whole numbers, right? Now, when I do slope, we often use the letter M to denote slope. And I know that it can be a rise over a run. So let's take a look at our rise first. When I'm going from this point, I need to go up all this way first, right? And when I count, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my rise is a positive 10 because I'm going up. And then my run is 1, 2, 3, 4. Now, maybe you guys know this, or you can use a calculator to check. You can simplify that fraction. 10 over 4 is the same as doing 5 over 2 because both numbers will divide by 2. So my slope for this function is 5 over 2. Try your student example number 1 on your own, please. Now the teacher example number 2 asks, what is the rate of change between 2 points? When you see this word, rate of change, you should think, what is the slope between these 2 points? Now it gave us 3, -1, -2, 5. So first thing that I'm gonna do is label X and Y. So X1, Y1, X2, Y2. Now, I want us to think back here. We were given this slope equation. So we're going to just use that right over here. And I'm going to rewrite it. M equals Y2 minus Y1 over X2 minus X1. So right here, M equals, what is my Y2 value? Well, Y2, right here, 5. Minus, what is my Y1? Now here I see Y1 is a -1, but I already put my minus here, so in parentheses, -1. Now my X2 is -2, and my X1 minus a +3. Now you can use a calculator, maybe you can do some mental math. 5 minus a -1 changes it to a positive, you get 6, and then -2 minus 3 gives you a -5. So your slope here is -6 over 5. We cannot simplify the fraction, so that is our final answer. Give a try, student example number 2. Now the last example that I want us to go through is when you're given a table to determine the rate of change. So again, when you see that word rate of change, we should be thinking slope. Now when you see a table, you have a list of x values and y values, which means I can pick any 2 of these and make coordinate points. 0, 3 is a coordinate point for when x is 0 and y is 3. 2, 11. 4, 19. These are all coordinate points from the table. So again, I can use my slope formula for any 2 of these points. So I'm just going to do the first 2, 0, 3, 2, 11. So I know my first x value, and then y, x2, y2. And I know my equation here is y2 minus y1, x2 minus x1. So y2, 11 minus 3 over 2 minus 0, 8 over 2, which gives me 4. And that's my final answer. So take some time, try your student example number 3. Remember, if you don't like negatives, you don't have to use the first 2 coordinate points. Honestly, maybe these ones are easier because they don't have any negative numbers. That's fine. Now remember, when you're writing your summary, I want one sentence about the main ideas and one question. All right, and that's all for today.